student AUB, and myself, Yves Dawood, first year mechanical student AUB. Our robot is Kotse. And okay, so our work plan. First, we brainstormed how we wanted to do the design, gather ideas and everything. Then we planned everything. We got a deal on everything. Then we did the 3D design. Our robot is fully 3D printed. No parts, excluding the motors and sensors, are 3D printed. So then we did the development. We prototyped for sure. We lost a lot of plastic, which was for waste, because as you see, we need to do prototypes to know which type works better with the robot. Then we did the coding, testing, and modifications final to get to the final robot. Okay, so the cost. We did our best to get the best cost. It's fully 3D printed. The other parts, we have an approximate cost of $400. The 3D printer facilitates everything. As I said, our robot is more than 90% 3D printed using Fusion 360. The 3D printers were the XYZ, and then the UpMini. The UpMini is more accurate, but it's more small, but it's faster. So we use the UpMini, the XYZ to print bigger parts, and the UpMini to create detailed parts. This is an Arduino Mega as a microcontroller. Okay, the interface is outside the door. Sensors, and EDC analyzer motors.
In the design, we have four main parts: the steering system, the main body, the sensors, and the crane. In the steering system, the first part we have is the wheel. The wheels are our steering system is special because each wheel can turn 180 degrees, not like typical cars. So the car can go in any direction. That's why we have to do a special steering system. In our wheels, we have one side of the wheel that can fit into the motor, and the other side can fit into what we call a U-shape, which is an essential part for our steering system. This is the U-shape and the wheel. And finally, we had to do our gearing system. The cylinder in the middle goes onto a servo motor. This servo motor, when it turns the cylinder, it turns the two other cylinders that are the two other wheels, and they are connected with a cable that we can see here on the robot. These are the gears and the cable. Now let's talk about the main body. The main body are three layers. Between the first two layers, there is the steering system. Between the two second layers, there is the electronic components and Arduino. And the last layer has the crane and the power supply. Now let's talk about the sensors. We have 26 line sensors because we have in one of the games, the Shawarma Express, we have a dashed line, and we found that the best way to do the dashed line was using this design. To work on the dashed line, we need 6 line sensors. Each 2 line sensors are separated by 3 centimeters. So between the first and the last, we have 6 centimeters. The yellow dashed lines are separated 6 centimeters. So the first 2 sensors can see the first dash. When they pass it, the second 2 sensors, and finally the last sensors can see it. So we always have contact to the dashed lines. And we had to do 4 of these 6 sensors because one for the right, one for the left, and our tactic was to send the robot to the front, deliver the shawarma, and go back on the same track. So we have to also duplicate them to the back. Now we had to do also ultrasonic sensors and finally color sensors. For the color sensors, we bought some from the market, but they weren't accurate, so we decided to create our own color sensors. To do our color sensors, we use LDRs and white LEDs and colored filament over the LDRs. When the white LEDs turn on, they send light to the surface. If, for example, the surface is red, we will have a red light coming back, and the red LDR will see it. And finally, we have the crane. The crane is used to deliver the shawarma. We have the main part, which is the tower. It's stable. And then we have the crane up, and it has a feeder at the end. That's a video how the feeder puts the shawarma. And this is the end for the design.
Okay, now for major problems we encountered. First, we did big wheels. The big wheels allowed more speed. So the thing that we had is, even though we put speed, the maximum speed to make it stop for the motor, the encoder motor, is 255. So even with 240, the motors weren't able to drive the wheels. So we were obliged to minimize the diameter of the wheels to minimize the speed, and thus we can go through the lines easier. So no line sensor is a market. We got to Katrange, CNC, everyone. No one had line sensors. Someone ordered 400 line sensors, and we were out of line sensors. What we did was create our own line sensors, but we didn't get them because we bought the new ones. But we experienced the line sensors, infrared, and we did the circuits, all circuits. Okay, not enough power. We had problem with motors and everything. They couldn't get more power. Burning servo, we burned many servos, 2 servos. That's why we called our robot Kotse 86. 8 means we gave it 8 volts. It needed 6 volts, so we burned 2 servos. Exploding voltage regulator, that was yesterday. We used a voltage regulator and we switched the poles. So we gave it minus and plus, and we had smoke. So burned DC motors, also yesterday at 5 o'clock before the testing ends. We burned 3 DC motors because of the voltage regulator and because of the poles that were allowable. So we got to Trablus at 5 p.m., got back home at 8 p.m., changed all the motors, and we weren't able to test it. So it's our first test today in the circuit. Okay, our strategy, as Guy said, line sensors could catch yellow lines at any point. And here, it's when left line sensors get white, they turn, and when black, they turn. So it's like we need to get between the white and the black. Here we use the same strategy as I said. Well, for the parking, we use our benefit or advantage with it that the robot can go parallel, so it can transition parallelly, so it's easier to park. Not the normal parallel parking that we do every day. We go. And for the shawarma, our strategy was to count the buildings by their color. So when we see, we know that 15 is one building, is 2 buildings from the left of the middle line. So that's how we did it. The robot will get to the building and then come to us, the pit area, to give it the shawarma. Okay. And thank you for listening. Because every industry, for their first product, for sure they burn something. But they give you the final product, which is the perfect product. So this is a perfect product, even though we had prototypes and motors that were burned. We learned by mistake. What is what? No, it doesn't include. This is the final product. And it's like we're selling it. And for iPhone, you don't get how many cameras they burn. Can you ask a question?
How heavy it is? How heavy it is?
2.5 to 3 kilos.
Was it the requirements to be within this volume and this way?
No.
No. The volume, yes, for the parking and for the roads. And it's area.
Volume? That's width.
لا width. Volume ما كان فيه restrictions.
So how do you detect the building which you want to cover?
With an ultrasonic sensor, we catch the first wall. We drive till we get to the second ultrasonic sensor, which is behind it. Then we.
Show us the ultrasonic. I'm seeing only one.
No. One in front. Here we have two. Here's the first wall of the
so
parking.
inside.
When both pass, it goes inside until these reach a certain distance. So
10
it doesn't
centimeters,
touch.
10 centimeters, 10 centimeters. So it's centered in the parking. So it learns by itself, not like others. We have a delay when we get and how we do it. No, it's any parking it can park it. One thing we did.
So you detect the first.
Wall.
So the first sensor detects
The first wall.
Yes.
And then the second sensor.
Then it goes a bit slower until the second.
Sensor detects the same.
Yes, and then it goes a bit further on this until this one doesn't see the wall anymore. So it's in the parking.
And then you rely on the two other sensors.
No, and these ones, so we turn the motors and it goes in until these become till 10 centimeters more or less, and these also, so it's centered in the middle.
You're taking feedback.
Yes.
From the side sensor.
Exactly. One thing we didn't mention is that for the King of Speed, which is a game they added recently, it needs speed. And what we said was that the wheels, we minimize them. So we did these brackets. Those are 65 diameter. So we have more speed. Okay, so here it's magnets. You just lift the robot, put them on the wheels, and you have more speed.
And because when we put these brackets, the robot will elevate a bit. These line sensors won't catch the lines anymore. And maybe it goes a bit left and right. So we have these sensors that attach a bit lower.
What is the payload of this robot?
Payload.
Wait, how much it can carry?
We don't.
Like here or where?
We know that the shawarma is 250 grams, but we know it can carry.
one shawarma.
Yes.
Yes, that's what they said.
Did you carry more?
No.
No.
Because I would. Yes. No. I would like to take. It goes. It puts the shawarma. It comes back for another one.
We have a counterweight. We can balance between them if we want. And we have here they are strengthened.
لا بس it can't feed more than one at a time.
No. Yes.
So you know that
Yes,
you
exactly.
have time to do that for the shawarma.
It's we don't have time limit, I guess. 2 minutes are for the first two games.
No time.
I
limit.
don't.
How long did it take in development time?
2 months. Yes.
Two first years.
Two first years.
So you've done everything by yourself. So you
Yeah.
did the first.
No, too long until then. When we had the power problem, we were using a breadboard power source, which is here, but it just gives 500 milliamps, which isn't enough for all our sensors and motors. So we had two options, or use diode because we need 3.3 volts, 5 volts, and 6 volts. 6 volts for the servo, 5 volts for the sensors, and 3 volts for the LEDs of our color sensor. So we had two options, or we use diode, or we use voltage regulator. We went for voltage regulator because if the battery voltage goes down, it will stay constant, but a diode will have a drop down of 2 volts, so it will always go down.
Thank you.